I'm Anil Kumar. Welcome to my series on quadratic relations. In this video, we are going to learn a very important topic, and that is how to sketch graph of any quadratic relation. If you really want to learn from me, you can send me an email on the address given here. You can also visit our website to see what we are doing at present. Well, how to sketch a graph of a quadratic function is the topic which is taken up in grade 9, 10, 11, and 12. So it is one of the most important concepts which we should learn early on. We'll actually discuss the parent function y equals to x squared and different transformations. We'll begin with y equals to a times x squared, where a is the stretch factor. So if a is negative, then the graph is reflected on the x-axis. If it is positive and greater than 1, the graph is stretched by a factor of a. But if it is between 0 and 1, in that case it is compressed by that factor of a. Now, you can modify the equation by adding up k, which actually translates the graph up and down. We normally use the vertex form of parabola to sketch the graph. If you know the transformations, this is one of the best equations to work with. Also, I'll teach you technique of just using the vertex and these steps to sketch a very accurate graph of a parabola. At times, you sketch a graph of parabola using the intercept form, where the intercepts x1 and x2 gives you the 2 points on the x-axis where the graph crosses, and then the midpoint gives you the axis on which there lies the vertex. And therefore, a very simple sketch can be drawn if the equation is given in factored form. Difficult part is when you are given the equation in the standard form, which is y equals to ax squared plus bx plus c. We'll explore in details how to sketch these graphs. They could be very tricky. So you could actually factor them and then sketch the graph as we will be teaching you those techniques. You could also do completing the squares and then you get that vertex form and then you can sketch them. Well, if it is not factorable, then the options are that you could do completing the squares, which is a very popular method. However, partial factoring is something which is not popular in many schools. However, this is one of the best ways of sketching graph of parabola. I am going to take this in details in this particular video, and I hope the students who follow on me on this particular video and the other videos will definitely learn this technique and will have an edge over their competitors. So now let's begin by understanding what exactly this graph is all about. Well, if you have a quadratic relation, we'll take a very popular form which you call the vertex form, y equals to a x minus b whole square plus q. Normally, a standard equation is actually converted to this form to describe the transformations and also to sketch the graph. So let me discuss all the parameters with the help of this particular equation itself. As you know, the graph of this function is a parabola. It is a continuous curve which actually has one turning point, and this turning point is called the vertex. If you are given this equation y equals to a x minus p whole square plus q, in that case the vertex is pq, right? So this value p, which makes the first term as 0 for x equals to p, right? And then the y value you get as q is the vertex, the turning point on this particular parabola. If the curve is opening upwards, that happens when a is greater than 0, then this represents the absolute minimum of the curve. If case a is negative, in that case the graph will be upside down and the vertex will represent a maximum value. We'll also learn that we can use these steps 1, 3, 5, 7 times a to get all the points on the graph and then sketch it very easily from the vertex. Well, you know that the y-intercept is a point where the x value is 0 and x-intercept is a point where y value is 0. Now these two intercepts are very, very important to label in your graph, right? So the critical points to label are, let me write them, Here, we need to label the vertex, y-intercept, and the x-intercepts. So for sure, minimum, these 3 points should be labeled whenever you sketch a graph, right? It is very clear. So finding x-intercept could be very tricky. Y-intercept is very simple since you have to just substitute the value of x as 0. You get the y-intercept. But how do we get the x-intercept? Well, one way to get the x-intercept is to factor, correct? So one way, of course, is to factor. Once you factor, you know the x-intercepts are x1 and x2, right? In this factored form. Well, if it cannot be factored, then you have to use the quadratic formula, correct? So this quadratic formula, which is x equals to minus b plus minus square root b square minus 4ac, should be applied to find the x-intercept, right? So that gives you a key. Now, if you are given the vertex form, in that case, vertex is very easy to figure out. You can multiply the steps 1, 3, 5, 7 with A and sketch the graph. We are going to explore it further. However, finding x-intercept is tricky. To find the x-intercept, we have to rearrange this equation, right? So we have to rearrange. Rearrange really means you have to take q to the other side. We are putting y equals to 0. Divide by a. So you get minus q over a. And then you have to square root. Whenever you square root, you write plus and minus. And then you take this p to the left side. So we get p plus minus square root of minus q over a. So that gives you the x-intercept. For the y-intercept, just substitute x equals to 0. So you get a simple expression to calculate. Perfect. So that is how, broadly speaking, we could actually find what is the value of the vertex, what is the value of the y-intercept, and what is the value of x-intercept. The figure here clearly indicates all. The x-intercepts are the points where the curve crosses the x-axis, while y-intercept, the curve crosses the y-axis. Axis of symmetry is through the vertex. And the equation always is x equals to the x value of the vertex, which is p in our case, when the vertex is pq. Got the idea, right? So this point is the absolute minimum. If the value of a is positive, the graph is opening upwards, but it could be absolute maximum if a is negative and the graph opens downwards. Clear? Now let's take up the parent function to begin with. So y equals to x squared is the parent function. You can always make a table of values for different values of x, minus 2, minus 1, 0, 1, 2, 3, and 4. When you square them, you always get positive values as shown in this particular table. Now, once you have these values, let us find the first difference. Now, what is first difference? Well, the first difference is the difference between y2 and y1, right? This is what first difference is. So as mentioned here, first difference between y values, right? For delta x, you know this should be continuous, right? And difference of 1. So we are increasing by 1. Do you see as we go? We have delta x equals to 1. The change for each point is one step. Do you get the idea, right? So if you are moving along the x-axis from 0, you move one step to the right, and that is what the change is. We are measuring the change for this horizontal step to what is the change in the vertical step. And this first difference and this first difference gives you the vertical change, correct? So let's find out the change. So I begin from the vertex. So this is our vertex, right? 0, 0 is the vertex. So let's begin from here and only analyze one side. Now it is important to analyze one side since because of the symmetry, right? So we have symmetry. And the symmetry is x equals to 0. So therefore, we are analyzing one side only. So when you do the difference, what do you get? That's what we're trying to figure out, right? So the first difference is y2 minus y1. So 1 minus 0 is 1. And then 4 minus 1 is 3. 9 minus 4 is 5. 6 minus 9 is 7. So what you notice here is that the numbers increase by 1, 3, 5, 7. You get the idea. So here we check that the steps are 1, 3, 5, 7, and so on, right? So that is how you get these steps. So what it really means here is that if you move one step to the right, the point on the curve, which was earlier at 0, moves one step up. Do you see that point? So the y value becomes from 0 as 1. Next time when you move one step to the right, this time it moves two steps up, then I mean 3 steps up, and then it goes 5 steps up, right? So that is how you can actually get the other points. You get the idea. So what I'm trying to say here is first we have step which is 1 up, and then we have 3 up, and then we have 5 up, and then we have 7 up, and so on. Now because these graphs are symmetrical, you can find the point on the other side because of the symmetry. So we could now find all other points on the other side, and then you can write down those points. So you have those corresponding points with you. Now you have your complete graph of the function y equals to x squared. You get the idea, right? So when a is equals to 1, right? Since y equals to x squared, in that case, these steps are 1 time 1, 3, 5, 7, 9, etc. So what you could do here is, how do you sketch this graph? You can start at origin. Why origin? Because that is your vertex. And from there, what you do next step is points using steps, which are 1, 3, 5, 7. Correct? So that gives you all the points, and then we have to use the concept of symmetry to get the other half of the parabola. You get the idea, right? So this was the y-axis, which is the line of symmetry for us. And on either side, what we have is the points, which are 1, 3, 5, 7 steps away as we gradually move. I hope this concept is clear. Correct? Let's move on and use the same concept to sketch the next graph. So next graph, what we have done here is we have taken up y equals to 2x squared. So in this particular case, the value of a is 2. That clearly means once I identify the vertex, so let me write down here. So we have the vertex, which is at origin again, right? And the steps will be 2 times 1, 3, 5, 7, correct? And so on, correct? So that means we begin with the first point, which is at the origin, and then we take the next point, we move one step, and then how much up? 2 steps up, right? 2, because that 2 is the value of a. And next time, 2 times 1, so this basically is 2, 6, 10, 14, and so on. Is that correct? So next step, when you go, the y value increases by 6, right? So you go 6 steps up, and so you have the value. 2 plus 6 is 8. You get the idea, right? And then add 10 to 8. And when you add 10 to 8, you get the next point, which is 18. Do you see that? This is 18, and this was 10. So that is how we keep on, that is 10, right? So 8. So 8 plus 10. So that is how you get these steps and your points on the curve. As you can compare it with dashed line, which is shown in green, of x square, right? So you could also do transformations. Every point has gone up by twice, right? So that is the transformation. Here we do have a table, and now again you can compare from the table that these steps are what? So you can see here that the steps are 2, 6, 10, and 14, just as we calculated at this particular point. But now what I'm trying to tell you, that you need not make a table, right? You can straight graph or sketch in 2 steps. So step number 1 is vertex, right? You may call 2 steps and then you may say 3 steps, because we are going to reflect and get the other half also. So first step is to get the vertex, which is at origin. Second step is to get those points on one side of the graph, and third is use symmetry. Symmetry is that now you have the one half of the graph. Now you have, those are the symmetrical points, correct? So you get the points on the other side and then you connect, right? Not on this curve, I'm sorry. This should be on the orange curve, right? So that is the graph which we are interested in. So you can actually use y-axis as your mirror and then get all other points. And there you go. You have your graph 2x squared. Is that clear to you? All right. Let's do it once again. And this time I have taken a value of a as half, right? So that really means what you're going to do. Step one is find the vertex, correct? So in this case, the vertex is x equals to 0, y is also equals to 0. That is the minimum. Step number two, you have to use the steps which are half times 1, 3, 5, 7, and so on. Correct? So that means a decimal value, right? 0 0.5, 1.5, 2.5, right? 3.5. Correct. Like this. So now we start with the origin itself, which is our first point. The next step here, as you can see, is 0.5. And then we have another step of 1.5, and then another step of 2.5, and the next step 3.5, and so on, correct? You get your steps. And then we go to step number 3, correct? Step number 3 is find the other side. So reflect on the axis. In this case, x equals to 0, right? So we are reflecting this point. So when you reflect this on the other side, what do you get? You get the other side, correct? So you get the other points on the left half of the function. Is that clear to you? Then you join the points and sketch the graph. Smooth curve with a turning point at the vertex. Is that clear? Then you join and then you get smooth curve, which is called parabola, with minimum at origin. Is that clear to you? That is how you are going to draw the very basic graph. Is that clear? Next part of this is to take up a function where we will also incorporate translation. Now the graph is to be sketched for the function y equals to minus half x squared plus 8. Now let me explain you one more concept, and that is the difference between sketch and graph. Okay, so whenever we say sketch, sketch really means a rough graph showing the critical values like vertex and the intercepts only. Let me write down here, only. That is what is meant by sketch. So you do not have to plot so many points to sketch a graph. So when we say graph a function, that means in details a fairly accurate one. But sketch is a rough sketch. Is that clear to you? So in this particular case, what we are interested in finding is one, of course, is the vertex, which happens to be at 0 and 8, right? So once you have the vertex, you know that the axis is at at x equals to 0. So you know at this point that the axis is at x equals to 0, right? This is the vertex x value, correct? We can find the y-intercept, substitute x equals to 0 to get y-intercept of 4. So we get the y-intercept in this particular case of 4. I mean, the equation written here is 8, right? So typing error. This is 8, not 4. So you have the y-intercept of 8. So that is the y-intercept. Now this is the vertex also. So it's a turning point. Since a value is negative, right? So we know that this value a is less than 0. So it opens down. Correct? And therefore this happens to be your absolute maximum. So you have to understand the function as soon as you see the relation, right? So we have an idea in our mind that we have a vertex right on the top, which is the maximum, and it is also the y-intercept. And what we are now interested in finding only the x-intercepts, right? So these points is what we are interested in finding. So what you can do is you can rearrange the the equation by substituting y equals to 0. You can rearrange and find the value of x. And of course, when you rearrange, you will say 0 equals to minus half x squared plus 8. Why 0? Because to find the x-intercept, we are substituting y equals to 0, correct? And then bring half x squared to the left side, multiply by 2 to simplify, and then when you do square root, don't forget to do plus and minus. So we get those two values, plus and minus 4, as our x-intercepts. Do you see that? Just sketch the curve connecting the vertex and the x-intercept. So that is the sketch. Do you see the difference? Earlier graphs, we were actually plotting the points, and we'll call this as graph functions. This is the keyword graph. Is that clear to you, right? Now, we are working on a sketch and see how simple it is. That is what we have to do when we have to sketch a function. When you have to sketch a function, remember, you have to provide details about the vertex and the intercepts, both x and y. Let's take up more examples to really work on this strategy. So this time, it is a question for you. You can pause the video, practice, and then we'll move on to the next question. Y equals to 10 minus 2x squared. As soon as you get this equation, you should understand that here we do have a maximum, correct? We have a maximum, we have a vertex which is at 0 and 10, and we know the graph is something like this, right? So we have an idea that we are looking at this point, and what we need to find is these 2 points. Is that clear to you? We are done. That means sketch. So that is what we have to do. Now to find these 2 points, what should I do? I will equate y equals to 0, rearrange, and solve for x-intercept. Is that clear to you? So that is how we are going to get these 2 points. Once we get these 2 points, we already know our maximum value, which is also the y-intercept in this case. Connect these points and get your graph. Is that clear to you? That is how we are going to sketch this particular function. Now, if I change the equation, and if I change the equation to graph instead of making this as a sketch, in that case, from the vertex, you may use the concept of steps. Multiply each step by minus 2, the graph will come downwards as shown here, right? Open down, and you'll have your graph, right? Clear? Now, we'll see how to sketch a graph when the equation is given to us in the vertex form. So that is one of the examples we'll look into. Y equals to 2 times x minus 3 whole square minus 18. Now here, what is the vertex? Well, 3 and minus 18 is the vertex, correct? So 3 and minus 18 is the vertex. Now, since this graph opens upwards, we know this is also the minimum value, right? So that is the minimum value. Now, since the a value is equal to 2, what should be the steps? Well, the steps should be 2 times 1, 3, 5, 7, right? Kind of like this. And so we have to identify what the vertex is, go to that point, which is 3 and minus 18. And from there, you can go to the steps, 1 times 2, which is 2, right? So you get 2 steps and then 6. So basically the steps will be 2, 6, 10, 14, and so on, correct? And once you follow these steps, you get your points on the graph as we have discussed earlier. Also, that is the second part. And the third part is use the axis to reflect and get the points on the other side. Is that clear to you, right? Now, in this particular case, what we find is while doing all this exercise, we also got our x and y intercepts. Do you see that? And this happens to be the y-intercept also, correct? Since it is at the origin. Now, we actually got our vertex, the x, y-intercepts, and all the points. The graph has been very accurately drawn. Perfect. So that is how you're going to draw the graph. Now, you may not be so lucky with the vertex form getting the x-intercepts. In that case, what do you do? Well, next example will explain you this concept. So here is another example, similar kind, but with a major difference. So we have almost a similar equation. The value this time is minus 2 times x plus 2 whole square plus 6. Let us see how to sketch this particular graph. Now we know this is a parabola which opens down with the vertex at minus 2, 6, and the steps will be minus 2 times 1, 3, 5, 7, correct? Okay, now we know the vertex is given to us. We can have these steps, and once we have these steps, we can have one part of it, and then we can reflect these points and get the other part of it. So we have actually sketched the parabola. So that part is called the sketching. So the sketching has been done, right? So this is sketching. Now, the question here is to graph the function. When you want to graph the function, we have to identify the x-intercepts very accurately. And therefore, we have to rearrange the equation and then find the value of x-intercepts. So what will you do? So to find the y-intercept first thing and also the y-intercept, right? So we have to also find the y-intercept. So let's see how to find the y-intercept. So for y-intercept, we know x is 0. Substitute 0 for x, calculate, and you get the value of minus 2, and that gives you the y-intercept. Clear? So we have this as y-intercept, which is at y equals to minus 2, right? So that is how we get it. Now let us see how to find the x-intercept. For x-intercept, y has to be 0. So y has been now put 0. Now you have to rearrange and solve for x, correct? So we have to rearrange. So when you rearrange, bring 6 to the other side. In this case, we brought minus 2 times x plus 2 whole square to the other side, and then divided 6 by 3, 6 by 2, which gives us 3, and then you square root it. Remember, whenever you do square root, you have to do plus and minus, and then take minus 2 to the other side. So that gives you the x-intercepts. So in this particular case, the x-intercept here will be minus 2 minus square root 3, and on the other side the x-intercept will be minus 2 plus square root 3, correct? You can also find the decimal equivalent value using the calculator. Perfect. So that is how you're going to sketch, rather you should graph the function giving all these details as shown here. I hope that is absolutely clear, right? Now we'll take another example. Let this be your practice test question. Okay, so I like you to pause the video, look into this particular question, draw, rather graph the function, and then check with my solution. So in this question, we'll begin with the vertex as we did earlier. So vertex in this case is the value 2 with a negative sign and plus 6. So that clearly means that the steps here are multiplied by minus, so the graph opens downward. So this is a parabola which opens downwards, right? So opens down, correct? With the vertex at minus 2, 6, and the steps minus 0.5. Minus means it is going to go down, right? 1, 3, 5, 7. As you can clearly see, there we go. We have a graph here which indicates these steps. And of course, once you do one side, you could do the other side also, or using the properties of symmetry, you can get the points on the other side, correct? Once you have connected them, then your graph is there. Exactly. However, in this process, we kind of could not get the value of the x-intercepts, right? How do we calculate x-intercepts? That is the next part to be done, right? So for x-intercepts, and in this case, we did get y-intercept, I think, but you can always put x equals to 0 and find the y-intercept, which was the value 4. So let me write down that we did get the value 4 of y-intercept with our steps itself, but we missed the x-intercepts. So how do we find the x-intercepts? To find the value of x-intercept, y should be equal to 0. Now again, rearrange and solve, right? So that is what you have to do again and again. So rearrange and then solve for x, correct? So when you do that, you again get radical function, and you can simplify as shown here and write down the value. So these are the two values for the x-intercept. One of them happens to be minus 2 plus, this will be minus 2 square root 3 on that side, and this one here is minus 2 plus 2 square root 3. So you do get conjugate, right? So you get conjugate values for the x-intercept in this particular case. right? So that is how you could actually do it. Perfect. So I hope this concept, when you are given the equation in the vertex form, how to sketch or how to graph a parabola. Remember, sketch means a rough sketch where we are only interested in the vertex and the x-intercepts. However, whenever it is a graph, you have to identify at least 5 points on the graph. Okay. So graph means at least 5 points. So let's continue and take the next example. Now we'll look into the factored form. So we are now seeing how to sketch the graph when the factored form of quadratic equation is given to us. So here in the first example, we have y equals to 2 times x minus 3 times x plus 1. We know the parabola opens up and it has the x-intercepts at x equals to 3 and x equals to minus 1. So we identified these 2 points. Now the case is, how do we get the vertex? So here we have to find the vertex and the y-intercepts because we know what the x-intercept is. So we know the x-intercept. To get the vertex, first we are going to find the equation of the axis. Axis is right in the middle. So which is average value of the intercepts, right? So it is the average of x-intercept. So we just add them up and divide by 2 to get the equation of the axis. So in this case, the axis equation is x equals to 1. Now on this axis lies the vertex. So vertex is somewhere at x equals to 1. Substitute the value x equals to 1 in the given equation and you'll find the value of y, and that gives you the vertex which is 1 minus 8, right? So we get this as a vertex here. So we can write vertex is now at v1 minus 8. Correct. So we have the vertex. We already know the x-intercepts. These values are known to us, right, from the equation itself. So we have a rough sketch of this. The question was to sketch. So we are done with this, right? You may draw arrows at the end indicating that it goes forever, right? So you know the domain is all real numbers, and in this case the range will be greater than or equal to the minimum value, which is minus 8. So let me write down here. Sometimes it is required to write domain and range. If required, you can say domain is x belonging to real numbers, right? And as far as the range is concerned, you may write y belongs to real numbers. However, y is greater than or equal to minus 8, right? So that may be a part of your solution sometimes, right? Now, let's look into the next example where we have a factored form and the graph goes through origin. This time, the equation is y equals to minus half x times x minus 6. You can see that it opens down, right? So it opens down, right? Not up. It opens down with x-intercepts at, well, this is copied from the previous one, at x equals to 0 and at x equals to 6. So these are the two x-intercepts marked here. Do you see that? And it opens down. The vertex has to be right in the middle of these. So we need to find what is this axis equation, right? So this equation of axis we can find by adding them up, which is 0 and 6 dividing by 2, and that gives you 3. So x equals to 3 is definitely the axis. To get the y value of the maximum in this case, substitute 3 in the equation. Once you do that, you get the maximum value, which happens to be 4.5. So we get a vertex here, which is at 3, 4.5, right? So the maximum value here is definitely 4.5. And you have your sketch, because in a sketch, you need to identify the vertex and x and y intercepts. So we have the origin as both x and y intercepts, and the other x-intercept is at 6. So I hope this is absolutely clear. Now, let's take another example, and this time we'll focus on standard equation, right? So this time the form is standard form, which is y equals to ax squared plus bx plus c. So y equals to x squared plus 2x plus 5 is the equation to work with. Now here, we do not know really what is the value of the vertex. But what we know here clearly is the y-intercept, right? So we know one thing, which is y-intercept. And we know y-intercept in this particular case is 5, right? When x is equals to 0, you can put, okay, so basically this, we have solved the equation which is, um, here it is 3, not 5. Okay, so let me change the equation. This was 3. So we are working with the equation x squared plus 2x plus 3. Okay, so therefore we have taken this as 5, not 5, but 3. Okay, so y equals to 3. So we are working with this equation which is not 5 here, but plus 3. And so we get a y-intercept which is at y equals to 3, is y-intercept. And whenever given in the standard form, you can put x equals to 0 to find the y-intercept. That is easiest thing to do. Now, how do we get the vertex? There are a couple of ways to get the vertex. One definitely is change it to the vertex form. So what we did here, we complete the squares. Is that clear to you? So we are showing you the process of completing the squares. Here, the coefficient of x is x squared is 1. So we just, and the base value, the coefficient of x is 2. So we just did half of that. We squared half of that, which is 1, and subtracted the same value. So which is itself a 1, right? So we get the vertex form, which is x plus 1 whole square and minus 1 plus 3 add up to plus 2. So we have a parabola with the vertex at minus 1 and 2. Clear? So we get a parabola with vertex at minus 1 and 2. The y-intercept is at 3. So with that, you could actually sketch it. Now in this case, since we have a y value of positive, which is a bare minimum, and it is opening upwards, there are no x-intercepts. Is that clear to you, right? So what you notice here is that the the parabola opens up in this case with minimum value which is positive, and therefore there is no x-intercepts. Now in standard equation, let me share with you, if I have y equals to ax squared plus bx plus c, in that case what we are actually trying to do is we are first finding the y-intercept, and then we have an option. To find the vertex, we could either go for this particular process, which is called completing the squares, right? Or, or there's another thing, which we call partial factoring. So I'll share with you the technique of partial factoring soon. Now, here is another equation, and in this case, again, we have the standard form of quadratic equation, which is y equals to minus 2x squared minus 4x plus 1. Now, in this particular equation, we are doing the partial factoring. So we'll do partial factor, not completing the square this time. So let me just write down here clearly, partial factoring. And see how partial factoring is performed and how easy it is to sketch the graph of a parabola using this concept, right? So this is a very important concept. So I'd like you to focus on this, right? This is the key. So look here. What we did was that we could actually factor the first two terms with minus 2x is common, right? So what we get here is minus 2x times x plus 2. Keep that plus 1 outside. Is that clear to you? Now, at x equals to 0, what happens? You get a value of 1, correct? Also, at x equals to minus 2, y value is 1. You get the idea. So what we're trying to say here is that we get a value of y equals to 1 for two values of x, which are at x equals to 0 and at x equals to minus 2. Is that clear to you? So we are saying that at x equals to 0 and at minus 2, we have the same value of y, a horizontal line. Is that clear to you? Now, since we have a horizontal line with exactly 2 points, they should be mirror image, right? So these 2 points are mirror images, right? About the axis, which is right in the middle, right? Do you get the idea? So, so that is the axis. X equals to what? So we have to find the average value. And this is what we did here. So we found the axis by adding these two values of x, correct? And dividing by 2. And so we get the axis at x equals to -1. You get the idea. So we have the equation of the axis. Once you have the equation of the x, you can get the vertex, correct? Now the next step is to find the vertex, which is the center point. So you substitute the value of -1 in the equation itself, correct? For x. Once you do that, you get the y value, which is 3. So we got this value y, which is 3 for us. So now we know the vertex. So you see how easily we could find the vertex of this particular parabola. Is that clear to you? Correct? So we know the vertex and we know the y-intercepts. So those 2 points are now known to us and we have the graph. From the equation, you need to find the x-intercepts. In that case, what will you do? Use quadratic formula for x-intercepts, right? So here we have a quadratic formula. Is that clear to you, right? So that is it. So you have the quadratic formulas. You get approximate values which have been marked. And that is how you're going to sketch this particular function. So I hope these steps are absolutely clear. You will see that it does not require so many calculations for completing the squares. Much simpler method. Well, let's take another example and let this be your trial test question. How do we sketch using partial factoring, right? So I like you to use factoring method to sketch graph. Okay. So once again, the first step will be from the first two terms, factor out whatever you can. In this case, it is minus 2x, right? So when you factor this out, then you know that for value of x equals to 0 and for 4, we get the value of y as 13, right? So this is that value 13. Do you see how they are connected? Correct? So once you know that, then we know this is kind of a horizontal line. In between, there has to be an axis, right? So in between, we have an axis. To find the value of the axis, find the average value. So the average value gives us the axis, which is basically x equals to 2. So once you have this line, which is x equals to 2, you know clearly that the vertex will be on this line x equals to 2. So now substitute 2 in this equation. Do you see that? So when you substitute 2 here, this is the calculation. So you sub 2. And when you do that, then you can clearly get a value, which is in this case the absolute maximum. So you get the value of absolute maximum. So what you see here is that the maximum, I may write maximum here at the value 221, which becomes the vertex of this particular parabola. So you have the vertex, you also have two other points. It's very easy to find the y-intercepts, which is one of our points of interest. Correct. To find the x-intercepts, what are you doing? Again, use quadratic formula for x-intercept. Is that clear to you? So if you cannot factor, in that case, partial factoring is a very effective way of sketching the graph. And that is where I want to end in this lesson. I hope you got the concept. Feel free to write your comment, share your views. And with that, we come to an end of this particular chapter where we have discussed what the parabola or the graph of a quadratic relation looks like. What are the different formulas or the forms of quadratic equation? One of them is the standard form, the factored form, and the vertex form. When these forms are given to us, how do we approach? There are different approaches as we have seen. How do we approach to sketch or graph the function? Sketch basically means that you need to identify the vertex, the y-intercept, and the x-intercept. But when you say graph a function, you have to identify 5 points at least. Let's be very clear about it. So the graph is much more accurate than the sketch. Now, identifying points, especially the x-intercept, may be very tricky. You might have to use quadratic formula at times, right? So we may have to have a quadratic formula if you cannot factor. Is that clear to you? So if it is not factorable, then use quadratic form or you factor. Is that clear to you? So those are the two things to find the x-intercept. Y-intercept is simple. Substitute x equals to 0. Is that clear? And for vertex, we have different techniques. One of them is completing the squares, and the other, which we learned, is partial factoring, correct? So partial factoring is a key thing which you learned in this video. And it's not very popular in many schools. If you adopt it, you have an edge over the peers. I hope that helps. Feel free to write your comments, share your views, and if you want to learn from me once again, you can always send an email. I hope that works. Thank you and all the best.